divided by 5, 13/5. 2.6. And how about the last one? 11 divided by 9. 1.2 repeating. So what we have up here are decimals, but there's two different kinds of decimals. These guys are what we call terminating decimals because they stop and this guy is called a repeating decimal because he goes on forever and ever. You've seen that a lot before. Right?
Yeah.
Now, if you look at all the decimals that act like this and all the decimals that act like this, together they are called the rational numbers. So that is a good thing to remember, that rational numbers can be either terminating or repeating decimals. All right. Graph on a number line. What do you think? Remember, this is all review. This should all look familiar to you. What's that look like on a number line? Closed circle at -2. Go to the right. And in terms of the number line, that's all you need. So I don't know if you're used to like drawing around putting 0 and all those hash marks. Don't worry about that. Just put the numbers on that will carry. All right, how about the next one? What does this look like on the number line? We're going to have two dots. We're going to have a dot at 5 and a dot at 6. Closed dot at 6 because of that, right? Open dot at 5. And they connect in the middle. We're shading in the middle. You are shading in the middle. And before you ask, why are we shading in the middle? Here is that X sitting in the middle, right? So we're going to shade in the middle. Yeah, it's bigger than 5 and less than 6, right there we are. What about this next one? I'm sure you talked about this last year. What do you know about that?
It's interval notation.
It's interval notation. We're going to graph it just like before. Clearly there's a 5 in the problem. Negative infinity's out here. I don't put a dot. There's no dot for negative infinity, but it's over there. What else do you remember about interval notation? Well, that parentheses indicates an open dot. And we're going to shade now in between 5 and negative infinity. So in other words, that's the same as saying x is less than 5. This is just the calculus way of writing that less than 5. How about D? What do you think this means? Again, we're bracketing it. We have -2 and a 3. Do you remember what that means?
So a closed circle for the bracket?
Closed circle for the bracket. This is closed. So that circle's going to be closed. That one's going to stay open. Parentheses are open. Do you think it shoots out? The only way it would shoot out is if it has an infinity in it, because outs are the infinities. So this is going to be in between. We're going to be in between -2 and 3. Okay, in between -2 and 3. What does this one mean? Now this one does have an infinity. So that means, here's my 7. And you already told me that's closed. Where's positive infinity? Out here? No dot. Do not dot an infinity. It's just over there. And that's the direction we're going to go. Because you can't dot an infinity, these will always be open. Infinity dot, or infinity brackets, parentheses, always open. Always. Okay, and then what do you think this one is? Take a minute and sketch that one on your own. Tell me what you got. On the number line. Open or closed? Both open. Shaded where? In the middle. You're never ever going to shade the arrows unless you have an infinity in your interval. Okay? Alright. Now we're going to write as an inequality. This is called an inequality. So now you're going to take this interval from 5 to 7. And you can graph it if you want, but that's not your job. Your job this time is to write it as an inequality with less than or greater than signs. Anybody have a thought on that? Well, if we did graph it, what would it look like? Open at 5, closed at 7, shaded in between. So if I'm going to write that as an inequality, I'm going to have a 5 and a 7, and won't my x be right in the middle? Because that's where I shaded. And I got to be bigger than 5, so 5 is less than x is bigger than 5, and less than or equal to 7?
Yeah.
When you write these, what they're called compound inequalities, when you write an inequality with two numbers like this, you should always be using less than signs. These are less thans. All right, B is different. What does B look like? If I graph that, what would that look like? 3 closed. To the left. Why to the left? Because that's where negative infinity is, right? So what would that be as an inequality? X is less than or equal to 3. Very. All right, try C. Try C on your own, or with your neighbor there, your friend. Does it look like that 9 dots filled in or open? Filled in? So if it's filled in, then hopefully this is what you wrote down as your answer. How's that? Is that better?
Yeah.
Follow the directions. All right, write as an interval. Now I'm going to write as an interval. I'm going to write like this now. For x is greater than 6. Now, if it helps you, think about what that looks like. Isn't that what that looks like? So what did you shade? You shaded everything in between 6 and infinity. That's your interval, guys. So 6 and infinity. The 6 is open. because that's just a greater than, and the infinity is always open. All right, try B and C with your partner. Remember that an interval is always going to have two numbers. One of them might be infinity, but you're always going to have two things in there. How's that look? Okay? And how about the last one? So graphing it on the number line would look like this. So you shaded everything between negative infinity and negative 7. So the 7 is bracketed, but the infinity is always open. You will never put a bracket on the infinity. It's always open. All right, rewrite using the distributive property. A, distributive property. Mn squared minus mq. Done. You know what the distributive property is. Don't look at me like that. You know. You just take m times both of them. What would that be? You factor it. I heard somebody say it. You factor it. Factoring is kind of the opposite of distributive, or the backwards of distributive. So what can I factor out of problem B? I can take out a 3, an x and a y, is that what you said?
Yeah.
So I'm going to be left with an x minus 2y squared. And of course you can check that. You multiply this back together, you should get what's on. All right, quickly, let's get through number 6 and then we'll be done. Name the property shown. Oh boy. Everybody's least favorite. Nobody likes properties, but guess what? We gotta do them. So here we go. Anybody know what anybody know what any of them are?
The identity.
What?
First one.
First one is the multiplicative identity.
Yeah.
Exactly. So what you need to write down is just mult ID. That would be good enough. If you want to write out the whole thing, that's okay. Multiplicative identity, but it's okay just to abbreviate. Wonderful. Who are you? What's your name?
Charlie Finn.
Charlie Finn.
Good job, Charlie.
Good job, Charlie Finn. All right. Who else wants to be impressive today? Anybody know any of the other ones on there?
Is G 0?
G is called the additive inverse.
Oh, no, G is 0. D is 0.
Oh, D, oh, wait, let's do G.
Well, I said G, but I also think D.
Okay, G is the additive inverse. Because inverses cancel each other out, and 7 and negative 7 cancel each other out. Okay? All right, what did you say, D?
I think.
D is actually the additive identity.
I'm good.
Whoa. you'll pick up here tomorrow. You know what you need to do. All is well.